In this lesson, we're going to be talking about relations and functions. Basically, a relation is a relationship between an x and a y coordinate, and functions are very special type of relations where every x coordinate is going to be given one exact y coordinate and vice versa. So we need to know a little bit of vocabulary before we start this unit. And we have two vocabulary terms up at the top, domain and range. A domain value is an x value, which we talked about in the previous sections, which is the input. So this is the input value that you're putting into a function. And then the range is going to be a y value. This is the number that you get out, or the output. We'll talk about a little bit more about that a little bit later on. We also have this word function notation. So function notation is where f of x represents y in a given equation. So we've been talking about function rules, which look like this: y equals 3x plus 5. Now, function notation is just basically taking that y and changing it to f with an x. And the way that we say this is f of x. And we're going to be doing a lot with that f of x, but basically what I wanted to show you is that these are identical statements here. That's just saying that y and f of x are the same thing, basically. All right, a little bit deeper. Here's the formal definition for relation. It's a pairing of numbers in one set called a domain, with numbers in another set called a range. And there are four types of relations that we're going to talk about today. And then the word function. It's a special type of relation in which each value in the domain is paired with exactly one value in the range, like I said earlier. So we're going to talk about that as we go through this section. Now, this concept is kind of interesting. It says find the range given the domain. So again, we need to remember what that range means and the domain. And the range values are going to be all the y values, and then the domain values are going to be all the x values. So really what it's saying is find the y values given the x values. So you can see that I'm given these three x values over here on the right. And to find my y values, I'm going to simply substitute those values in for that x that I'm given. So we're going to set it up into three little pieces here. So if I set y equals to 3, I'm going to use the -2 first. I'm going to go ahead and use that replacement value. And I want to do that to solve for my y. So I have -6 plus 4. So y is going to give us -2. So -2 is going to be my range value, or my output value. I have two other of these to do, so let's go ahead and do that. Y equals, this time I'm going to go ahead and I'm going to substitute the domain value 0 into x. And I'm going to go ahead and solve. So 0 plus 4, that's a nice easy one, is going to give me 4. So that's my output value. So my input value was the x value, and then the output is my y. And then I have one more to do. Y equals 3 times the domain value of 5 plus 4. So you can see here that I have 15 plus 4, and y is going to equal 19. Okay? All right, great. Now that we have these values here, what I want to do is just kind of show you what it looks like on the coordinate plane. So the first coordinate that I have is going to be that -2 is my input value, and then -2 is my output value. So -2 is going to look like that. And then my next one will be a domain, or my input of 0 and my output of 4. And I don't know what I was thinking when I chose 5, but 5 and 19 are going to be my other coordinate, and they're going to be way off my coordinate plane, so I'm actually not going to graph that one. But you can see that this function is going to create something that looks like this. But what I really wanted to do with that example was just kind of show you how if you input a number called a domain, you can export or output a number called the range. Okay, now let's go ahead and talk about this function notation. So function notation, like I said earlier, is this f of x. F with a parentheses, with the x inside, f of x. And here's how it works. It's kind of interesting. I'm given the function f of x equals 2x minus 1. And then it says, what is f of 3? Notice that that value right there is in the same position as the x. That's just saying, well, what is this whenever x is 3? Well, I'm going to say f of 3 is equal to 2 times 3, because I'm going to substitute that 3 in for the x value, minus 1. And then I'm just going to solve it out. So f of 3 is going to equal 5. So what it's saying is when I have a function and the x, this particular function, and when the x value is 3, my y value is going to be 5. Let's try it with a more complex problem. This says, what is f of negative 2? All right, notice that I don't have a linear function anymore. I actually have something called a quadratic. So let's go ahead and try it. F of negative 2 equals, I'm going to go ahead and plug it in. Use the skills that we've learned with the parentheses. So I have negative, and then I have negative 2 squared minus 2 times negative 2 plus 4. And then I'm going to use my order of operations to simplify this. So that's going to give me negative 4 plus 4 plus 4. And then that's going to give me negative 4 plus 4 is going to be 0 plus 4, which simplifies to 4. So my f of negative 2 in this particular function will be 4. So when I put a negative 2 in for x, my output is going to be 4. All right, let's talk about some relations, the 4 different types of relations. The first type is a set of ordered pair. Sometimes you might see a set of ordered pair that looks just like this. All it is literally a set which is 2 or more ordered pair put together. And what we want to do is we want to not only write them in the proper notation, but we want to figure out, is it a special type of relation called a function? So first, let me show you how to write it in proper notation. What I want to do is write my domain out by just taking those x values and putting them right into a pair of braces that I have here. So I'm going to do, and I also like to put them in numerical order, so the smallest to the biggest. That's a personal preference of mine. But you don't even have to if you just want to do 7, 5, negative 2, negative 6. That's perfectly fine as well. And then my range values are going to be all of my y values. So I'm just going to go ahead and put those in there, 3, 0, 4, and 2. And that's how I indicate it in the notation. Now, the question is it a function? Basically, to determine a function, all we're going to do is look at those x values. So we have 7, 5, negative 2, and negative 6. And the question is, if any of these repeat, that means that it's not going to be a function. But you can see in this first example that all 4 of those x values are different numbers. That means that this is going to be a special type of relation. It's called a function. All right, let's try another one. So let's figure out the domain of the first one. You can see that I have 6, 4, 6, and 5. Notice that the 6 are repeating. When I write it in my notation, I do not have to repeat the 6. So I would write something like 4, 5, and I'm just going to write 6 just once. My range, on the other hand, if you look at that, 5, 3, 4, and 8. All different numbers, so I'm going to rewrite those as 5, 3, 4, and 8. And again, you can write those in numerical order if you'd like. Now the question is this a function? And all we need to do is look at those x values. It doesn't matter at all about the y values, it just matters about the x. You can see that we have a 6 and we have a 6, and therefore they repeat, and therefore this is not a function. All right, how about this type of relation? This is called a table of values. Now, you're probably wondering, well, can I take a set of ordered pair and put them onto a table of values? And you're exactly right. These are interchangeable relations. And we're going to do that at the end. So let's look at the table of values and figure out, okay, how do I write this in a notation? And let's determine if it's a function or not. So to put it in our notation, all we need to do is look at those x values and then the y values. So I'm going to go ahead and write my domain values as 4, 9, negative 9, and negative 3. And then you can see my range values are all the same. So I'm only going to write my 2 just once. Now to determine if it is a function or not, all I need to do is look at that first column, my x column. And I can see that none of them repeat. I understand that I have a 9 and a negative 9, but we know that those are not the same numbers on the number line. So they're not the same, which means that this is going to be a function. And the last example here, again, we're going to go ahead and look at our x values first. and we're going to write those out. So we have 6, -4, and 3. And you can see that 6 repeats, so I'm not going to rewrite 6 in the domain. And then the range is going to be 7, 3, and 0. Now, just to determine if it's a function, all I need to do is look at those x values, and I can see that those 2 x values repeat, and therefore it is not a function. Okay, so we've looked at the relation type of a set of ordered pair and a table of values, and I still have 2 more for you. This is called a mapping. A mapping is basically 2 ovals or egg-shaped kind of figures, and the left-hand side of the figure is always going to be the domain, or the x values, and then the right-hand side is always going to be the range, or the y values. And what it's indicating to us is that each one of these coordinates from the domain is corresponding to a range value. So in this first example, you can see that 3 is going to 0. What that's doing is it's creating the coordinate 3, 0. And then below it, you can see that it's creating the coordinate 5, 8, and so forth. So what we want to do is figure out, well, is it a function or not? Well, we have to first look at the domain, and we have to ask ourselves, are any of the domain values repeated? It looks like 3 is going to 0, 5 is going to 8. I can even write them here. -7 is going to 4, and -2 is going to -6. Therefore, you can see that none of the x values repeat, and therefore this mapping is a function. Now let's look at the second example. So if you look at this, it says -2 is going to -3. Do you also see that -2 is going to 14? And then we also, of course, have 6 going to 9. Therefore, we can see that 2 of the x values are going to different values of the y, or of the range. This cannot happen. You can't have a domain value going to 2 different range values. And therefore, this is going to create a relation that is not a function. Sometimes the way that I like to remember it is if you have a situation where it creates a less than in your mapping, then it's always going to be not a function. Okay, let's look at another one here. This is a tricky one because you can see here that the range value looks like it's repeated, right? But again, sometimes it's helpful to write out the coordinates. 6 goes to 8, and then -7 is going to 8. -4 is going to 8, and then 1 is going to 8. So you can see that the y values are going to be repeating, but the x values are not. So this indeed is a function, but can be very confusing if you, forget the fact that it's all about the x's. Okay, the last relation we're going to talk about is my favorite. It's the graph. And this kind of brings it all together and kind of explains why we have this whole function, not a function. So let's say that we're given a graph, and to determine if it's a function or not, we have to look at this thing called the vertical line test. The vertical line test is a visual way to determine if a curve or a line or anything is a graph of a function or not. So a function can only have one output y for every unique input x. So let me show you what I mean. So what I want to do is just draw a line through this graph, and the line has to be vertical. So I'm just going to go ahead and I'm going to draw a line right here. Notice that my line that I drew only crosses the given graph at one location. If it crosses it at only one location, that means that this is a function. Now let me show you one that's not a function. Take a look at this one. Let's say that I put a nice vertical line right through this graph. Notice that it goes through 2 locations on this line. That means that this is not a function. And here's why. Let's say that this coordinate right here is -5, +2. And let's say that this coordinate down here is -5, -2. Notice how my x values are the same. Therefore, this is not a function. And we know that they would be the same because a vertical line would be on that same x value. So that's how you determine if a graph is a function or not. So let's try 2 more. I'm going to go ahead and I'm going to put my vertical line right here. And you can even move that vertical line side to side. And if that vertical line crosses 2 locations, it automatically is not a function. But in our case here, it crosses it once, so that is a function. And then I'm going to go ahead and I'm going to put my line right here. And you can see that it crosses here and here, which is 2 places, which that's not going to work. So this is not a function. So these are the different types of relations, and hopefully you're able to grasp that concept of function. Now, what we're going to be doing basically throughout the entire course of algebra is working with different relations and transferring them between the 4 that we talked about. The one that we're not really going to talk about all too much is the mapping, but it's good to know. So let's just take this set of order pair that we're given, and let's just translate it onto a table of values, a graph, and a mapping. So I'm given, let's make a table of values first. So my first order pair is -3, 3. So I'm just going to go ahead and write it this way. They still mean the same thing. And they're just different representations of a set of order pair, to be honest with you. Oops, -5 and 2, and then 1 and 4. So those two are just different relationships. It's the same function really. It's just 2 different ways to represent it. I'm going to put it on a graph here. So now I have -3, 3. I have 5, 0. I have -2 and 4. I have -5 and 2. And then I have 1 and 4. Now you might be wondering, well, am I going to go ahead and connect these dots? No, because a set of ordered pair are just ordered pair. It's just an x value and a y value, an x value and a y value, and so forth. It is not a linear function. So I'm just going to leave it just as is. Okay, and the last one, the mapping. All right, let's go ahead and let's just go ahead and look at my x values first. -3, 5, -2, -5, and 1. None of them repeat, so let's go ahead and write those out in numerical order. I'm going to do -5 first, then -3, -2, 1, and 5 are my domain values. My y values, let's see what they look like. 3, 0, 4, 2, and 4. You can see that my 4s repeat. So in my little egg over here, I only need to write that 4 once. So let's go ahead and do that. I'm just going to do, you can do numerical order if you like it. It really doesn't matter, to be honest with you. So let's do 0, and then 2, and then 3, and then 4. And then you're just going to draw your lines with your arrows. So let's see, -5 is going to 2. So I'm going to go ahead and draw him with a little arrow. It's important that you put that arrow. 5 is going to 0, so I'm going to go up this way. -2 is going to 4. -5, did I already do that one? Oh, I already did that one. Why did I do that one? Yikes. Which one did I do? -3, 3. I'm sorry, I was like out of order there. And I'm missing 1, so 1, 2, 4. Alrighty, just because those 2 arrows here at the bottom are going to 4, it still means it's a function, because remember, it doesn't matter if the y's repeat, it's all about the x's. So this is just a way to take one relation and transfer it between relations. Alright, that brings us to the end of relations and functions.